Alright, so let's talk about exponential functions. So exponential functions look something like y equals 2 to the x power. So we're taking a base number, like 2 or 4 or 5, and raising it to an x value. And the x values could be negative, it could be positive. So with this first one, what I'm going to do is I'm going to walk you through each of these steps. So you've got y equals 2, and then we're going to plug in 0 in for x. And if you guys remember back from when we were talking about exponents, 2 to the 0 power is always going to be 1. And then we just keep going down the list. 2 to the first power is 2. And then you've got 2 squared, which is 4. And at this point, you should start seeing that pattern. So we did 2 to the third power, which is 2 times 2 times 2, gives you 8. And if you look, as you keep jumping to the next y value, you're doubling. So this one would be 16, this would be 32. So it's going to be very important that you fill out that particular t-chart for me, and then plot as many points as you can on the coordinate plane. So here we would just be able to plot my 0, 1, 1, 2, and then we could do 2, 4. So you should see a curve similar to this. All right, so let's look at the next one. So now you've got 4 to the x power. So again, we're plugging in the values of 0 through 5. So 4 to the 0 power is 1. And then 4 to the first power is 4. And then 4 to the second power is 16. And you guys should see the pattern again, that we're just multiplying by 4 each time. 4 to the third power is 4 times 4 times 4, which is 64. And then if we keep multiplying by 4, you've then got, when you plug in 4 for x, you get 256. And finally, it would be 1024 for the last. So now when you go and plot these points, the points that you're going to have to plot are 0, 1, 1, 4, and that's really about it that you can plot on this particular coordinate plane. Alright, so with this next one, we're still working with exponential functions, but this time we've got a number that's less than 1 that we're raising to a power. So here you've got y equals 1/2 x, the x power. So we're going to plug in 0 in for x. Anything raised to the 0 power is 1. Then plug in 1 for x. 1/2 to the first power is 1/2. Then you've got 1/2 squared, which is 1/2 times 1/2. And in the end it becomes 1/4. So you should see the same pattern with the denominators as we did with our very first example. So you start off with 1, then you take a half, which is 1/2 of 1. Then as you look at the denominators, it's just doubling each time. So when we plug in our 3, that's 1/2 times 1/2 times 1/2, which is just 1/8. Next one would be 1/32, and finally, oops, yeah, you caught me, should be 1/16, and then 1/32. Okay, next example. Again, we're working with a fraction for our base, so we need to go through and just plug in our values. So anything raised to the 0 power with the first one is going to be 1. 1/4 to the first power is going to give us 1/4. And then we go over here, and then we've got 1/4 to the second power is 1/16. So again, you're seeing that the bottom is being multiplied by 4. So to kind of save us some time, the bottom would be 64 on the next one. When we plug in 4, it'll be 256, and the last one, 1024. So now that we've kind of figured out these t-charts, the way that these are graphed is going to be a little bit different. So if we go back up to section 3, that example, when we plot, we're still going to have that 0, 1, but when we go over to plot 1, 1/2, we see that it's just going to keep getting smaller and smaller. So it looks similar to this. Right, so it's kind of reversing. It's exponential decay. When you get down here, same idea, but it's just going to get closer to my x-axis quicker. Never touching it, but that's why the important part of this is to make sure that your t-chart is filled out correctly so that I can see what you're graphing. Okay, next example. So example 5 is going to kind of take a new twist on this. So we're adding a number in front of the 3 to the x power, and we're also subtracting 2. So let's go through and kind of work through the first few. So we've got, I'm just going to write over on this right hand side. So you're going to have y equals 4 times 3 to the 0 power minus 2. This we know, 3 to the 0 power is 1, so you have 4 times 1 minus 2, which is 4 minus 2, which is 2. Right. Next, we're going to plug in our value of 1. So you're going to do 3 to the first power minus 2. So you have 4 times 3 minus 2. 4 times 3 is 12. 12 minus 2 is 10. Okay. Now you plug in your 2. So you get 4 times 3 squared minus 2. So that'll be 4 times 9 minus 2. So now you have 32 minus 2, which is 30. Then we move on to the next one. You're going to plug in 3. So you have 4 times 3 cubed minus 2. So you do 4 times 27 minus 2. 40. 4 times 20 is 80 plus another 28. So that's 108 minus 2 is 106. So I'm going to stop here. You guys see the pattern of what you need to plug in for x. We go over to our graph, and like I've mentioned before, this is just going to, you're not going to be able to draw everything, but I'll have a good idea of what you're doing and making sure that you are filling out the rest of this table. Alright, next couple examples. So if I'm just giving you a chart, the way to figure out if it's going to be an exponential behavior is you look here, and you're going to find basically what's called a common ratio. So you take your 6 and your 1, and you do 6 divided by 1, which is 6. Then if I look at the next term with 6, which is 36 divided by 6, that should provide me with the same number. And if you keep checking or keep multiplying by 6 each time, that you'll get up to this 1096. So this first one is yes, it's exponential. When you move on to the next one, always checking to see if you're adding or subtracting first. So here I see if we add 4, we get 9. If I add another 4, I get 13. So because we're adding or if you're subtracting, it's linear. So it's not exponential. Okay. And then from here is our word problem. So it talks about you have a regional quiz bowl competition. 3 schools compete, and the winner advances to the next round. Therefore, after each round, only 1/3 of the schools remain in the competition for the next round. Suppose 729 schools start the competition. The exponential equation describes the pattern. So you have this, your starting point, which is your 729, the amount that it reduces each round, and you're raising to the value of x because it's exponential. So if we want to, we just go through, and you're just going to, you can either do this 2 different ways. You can make a t-chart, and you can say, all right, well, after 1 round, I need to divide 729 by 3. Because 1/3 to the first power is 1/3. So when you take 1/3 of 729, you're dividing. So you have 2. 1, 3. So you have, after the first round, now you only have 243 schools left. After the second round, you're just going to literally take your 243, and now you're going to divide that by 3 again. So you remember, we're just dividing by 3, or you end up multiplying if it's exponential growth. So here it ends up being 81. And then if we plug in 3, So 81 divided by 3 will give us 27. So after 3 rounds, how many schools? 27. So now we want to know how many rounds will produce a champion. So to do that, we're just going to kind of keep going. So if we take our 27, divide that by 3, we're going to get 9. If we go 5th round, divide 9 by 3, you get 3. And then finally, if we divide 3 by 3, you get 1. So after round 6, you'll have a champion.